Good afternoon, everyone. Today we're going to continue our discussion on uh, linear regression. We're going to move from simple to multiple linear regression, which is the real deal. So let's start first with a quick review of what we have done so far. So make sure that you have these packages loaded. I think GG45. We also need that and GG Okay, so these are some of the packages that we need. Let me just share this with you in case you don't have this. Okay, so notice I did not put here tidyverse. I just put directly ggplot2 with our dplyr because sometimes it's better to to install the package directly. All right, so I have run this, so I will not anymore run it. And I hope you have loaded the wage data set, the one that we have been using the past few sessions. And we said that it's important that you load save the data set inside your R project so that let's say, accessing the data, importing the data becomes a lot, a lot easier, a lot simpler, because you can just name the data and then load it instead of you having to name the exact file location. Okay. Then we already examined the data. We learned that the data, this is just a quick review, has 8 variables in it. Our variable of interest is hourly wage. We'd like to predict hourly wage using the 7 other predictors. So education, experience, tenure, race, gender, civil status, and number of dependents. We have 1 dependent variable and 7 independent variables. For our independent variables, 3 are categorical and 4 are quantitative. Okay, so this might be a concern later on, this categorical variable. But we can, of course, use categorical variables, in particular, the factors, the ones that can be used as classifiers. Okay, so we take a look at okay, so let me first, okay, I'm sorry about this, because I have to redo this. Okay. So let me just delete everything first. Okay, because I'll do something later on which will require us to modify some variables. Okay, so let me redo this. Let me load the wage data set. And then we take a look at the structure. We know that this is a data frame. And some of you were not able to get the questions for the data frame. Okay, so maybe I'll discuss the answers there, maybe just next meeting. We just have to finish this first. So data frame, then you have the numerical variables and then your characters, character variables here. Okay, and then we can take a look at the levels. For example, race is a categorical variable. We can use a table function to determine what are the levels in the race variable by with the table here. There are 54 non-white and 472 white workers in this data set. Okay, so last time we also did some descriptive statistics using these packages. Okay, so I will skip that. And one thing we said last time when we do regression, we would want your linear independent variables highly correlated with your dependent variables, but not your independent with independent. So one way to check that is to create a correlation plot You can use the core plot function, or you can use the pairs.panels and also the GG pairs from GG-align. So from the wage data set, we'd like to remove the categorical variables. They are from columns 4 to 6, so that what remains is just the numerical variables. So here I'm creating this object, wage 1. We already did this before class, so I'm not going to stop and wait for you to do it, because I'm sure you have this in your notes. And then I'll just use the GG pairs to come up with a correlation plot. Okay, you can see here that this is our hourly wage and its correlation with the other numerical variables. There's only one that's not statistically significant, the number of dependents. The others are statistically significant. In fact, to answer the question last time, that if we're going to choose just one variable to explain our dependent variable, it will be education, by virtue of having the highest correlation with hourly wage. Okay. So what we did last time was to create a linear model. Okay, this one, we created model 1, and then we used the LM function linear model. And this is the workhorse of regression model. Of course, there are other types like GLM, other types of linear model. So hourly wage, the dependent variable, is associated with education. So this is just a simple linear regression. And then to generate the result, so if I run this mod 1, it will create an object here in our environment, which is a list here, list. Okay, so we can access what's inside our LM object by using the names. And so here are the 12 elements inside your model 1. You can, of course, also access the elements here. For example, I'm going to type mod 1 and then $sign. So it has a intelligence. Arrow down, you can get the values that you want to get. For example, coefficients. Run this, it will give us the intercept and parameter education, the value of that. Okay. Now for this one, class, summary, it will give us the regression output. We discussed this in great detail before. So this is your parameter education. The value is 0.54 and it's statistically significant. The intercept, negative 0.9, but it's not statistically significant. But we said that the practice is that if the intercept is not significant, it still forms part of the model. The 3 asterisks here signify that this is significant at 0.1. Sorry, class. At the 0.1% level of significance. And we we studied what 0.54 means. It means that for every 1 year increase in education, year being the dimension of education, there's a corresponding $0.54. Dollars, because dollars is the dimension of your dependent variable hourly wage. Increase in hourly wage ceteris paribus. Okay, then we looked at the figures here. The residual standard error is just the standard deviation of your residuals. 524 degrees of freedom, we learned that this is n minus k minus 1, n being the number of respondents, which is 526, minus k. K is 1, which is education, 1 parameter, 1 predictor, and 1 for the lost degree of freedom, because we're also estimating the intercept. So there are 524 degrees of freedom. This is needed in order to compute like your probabilities, your p-values, and it's needed here for your F statistic. Okay, we also learned that we have the multiple R squared or adjusted R squared. In this case, adjusted R squared is 60.32%. which means that uh, your model using education can explain 16.32% of the variability of your dependent variable hourly wage. What happened to the 83+%? Well, it can be explained perhaps by other variables, right? And then this is coming from our goodness of fit test, which again, many of you missed that F stat and the low p-value. I was expecting you to write there. It comes from the goodness of fit test, where your null is your beta 1 is equal to beta 2, etc. is equal to 0. So this indicates that if there's a high F stat and low p-value, indicates that overall your model is able to explain your variable, your dependent variable. Okay, and mention the hypothesis there. All right, so now I did not mention yet last time the AIC and the BIC. So the AIC class is okay, the AIC is so this refers to your Akaiki Akaiki information criterion. And this one, BIC, is your patient information criterion. Practically, they're the same. They're just they're measuring information loss. Okay, so the lower the AIC and the BIC, the better. It means lower information loss. So if I run this, let me delete this first. If I run the AIC and the BIC, so you have 2777 and 2790. Now, this will not have any meaning at all unless it's compared. Okay, the AIC and BIC is used to compare models. The lower the AIC, the better the model is, right? So there are other ways to show your regression output. One way is through this. I don't think I shared this with you last time. So you can use a JTools package, and it has a function called sum, and it will yield quite a good, relatively better regression output compared to the summary function above. So why don't you run this class? Why don't you run it, and then you'll see that it's the tabular output here is better. The summary output is better than the summary function coming from base R. Right? So model info, you have 526 observations. The dependent variable is defined. The type of regression, OLS linear. And then you have the F stat here coming from D1 and D2, degree of freedom 1, the number of predictors. Degree of freedom 2 is your n minus k minus 1. And you'll need this in order to compute for your p-value, which we learned last time. And then the R squared, the adjusted R squared. We said that this will matter when we go to multiple linear regression, because every time you add a variable, you will be penalized for adding a variable as a predictor. Okay, then you have the parameters, education only, and then estimate, standard error, p-value, and then the p-value. Okay, so that sums up what we can get from the JTools sum function. Okay, let me pause for a while. I think if you kindly chat, please, if so far we're okay. I'm sorry if my pace is quite fast, because this is just a review class, except maybe for the AIC, BIC, and then for this one. Okay, good. Thank you. Okay, so I'm sorry, class. Let me. Okay, now we can get information about the residuals. So last time, I think I introduced to you the Broom package. It has this augment function, which will generate a data frame of information about our residuals, because we said that it's not enough for us to generate the model, come up with an equation about hourly wage, which, as we discussed last time, is just the intercept negative 0.90 plus 0.54 times your education plus residuals. Okay, so we can make use of this augment function coming from Broom. Okay, let's run this. And we can see here that we generate this. This is your dependent variable, hourly wage, independent variable. This is your fitted value, and then these are your residuals. Okay, the rest class will be of no particular interest to us except for the Cook's distance, which is very important in determining which of these points are influential points. Influential points are important because they can they can drastically change the value of the values of your parameters. So this needs to be looked into. Okay, so take note of this. I'm going to show you a plot which shows the Cook's distance. All right, so let's go back here. Okay, so we can now plot. I think I shared this with you last time. We can have now a plot of our points, of our scatter plot of our education and hourly wage. We can get that from the mod1.receive, which we created. And then we define the X and the Y axis. Aesthetics defines the X and the Y axis. Education and then hourly wage plus geom point, which will plot the scatter plot for education and hourly wage. And then this will include now the regression line, okay? And this will include segments, lines, okay? Vertical lines class, geom segment. And it will give us the beginning and the ending point, or the ending points class. And color is equal to red, and then just give the size. Okay, I think we discussed this last time. Okay, so if I just plot here, we got this last time. So these are your observed values, the dots there. This is your fitted value. And last time we showed that the mean of X and the mean of Y all form part of your regression line. So they're part of the regression line. So they should be in the line. yung point na average X and average Y. Average ng hourly wage and average ng education. Okay? So the vertical lines joining the observed value and the fitted value, the blue line, is your residual. Okay? And the regression line is called the line of best fit, and it's the smallest squared residuals. It will have a characteristic where the squared residuals is at a minimum. Okay? Okay, now let's go here. We can also plot, we can generate a plot here. Okay, let me first delete this. Okay, so kindly write this. I'll share with you this Control C, these notes here. Okay, once we have our model class, our regression model, we can make use of the plot plot function to generate some plots. Here I'm including a function here. So let me just make this 2 by 2. So this is let's partition the rows into 2 by 2. So there will be 2 rows and 2 columns. Okay. Let me delete this. Okay, and if we run this class, it will generate 4 plots. Okay, this one, residuals versus fitted, it tells us something about the linear relationship between your dependent variable and independent variable. Now you take a look at these numbers here. This could either be outliers or influential points. This tells us about the normality of the residuals, the QQ plot. If the if the plots here are very close to the line here, this dotted line, then it indicates that the residuals are normal. So this has something to do with the assumption that the residual should be normally distributed. But as I said before, that's the least of the requirement that we're interested in. This one class tells us about heteroscedastic distribution of the residuals. You can see here that it's not in particular a straight line, okay? And this one also about heteroscedasticity. But this one we're going to discuss in greater detail when we go to after our multiple linear regression. Now, actually, there are 6 plots that are given here. And if I, for example, if I change this into 3 by 3, it does not give us the 3 rows and 3 columns, or maybe 3 rows and 2 columns, because 3 by 2 is 6. It still does not give us the, sorry, run this all. Okay. 3 by, hindi nagkasya sa ano, no? I'll make it 2 by 3. So 2 rows and 3 columns. Oops. 2 rows and 3 columns. Let's see what happens here. Okay. So 3 columns, pero it did not plot all the plots that can be generated from this one. So what we can do here, class, we can define this. So we can define this one at a time. So which, we can write here which to signify which of the plot do you want to show. So which is equal to 1 will give us the first plot. So that's the first plot. Okay, and if I itemize this, which is equal to 2, it will give us the second plot that can be gathered, that can be obtained from the plot function. So that's plot number 2. If you check this class, this is up to 6. So there are 6 plots that will be generated here. There. And you can see here, Cook's distance versus Woodbridge. There, these are problematic observations. This might tell us that this may be influential data points. So 112, 59, and 379. Okay. Remember, there are 526 observations. So this is the number of the observation. Okay. If I click 5, it will give us plot number 5, residuals versus leverage. Okay. If I try 7, okay. So, wala. Walang 7. So, wala, no? So, dapat 1 to 6 lang daw yan. So, if I, which is equal to C, 1 up to 6. Okay, so if I define that all 6 plus, all 6, so it will give us 6 plots here. 1, 2, 3, 4, 5, 6. 6 plots about the residuals. Okay? I will discuss this, as I said, in greater detail when we go to the final model. All right? And you can plot this also using autoplot. Okay? So use the GG45 package and then use the autoplot function, mod 1. It will give you this. GG45. So this is the plot, similar to the plot a while ago. Okay, and let's see if this will also give us which is equal to C1 up to 6. Let's see if this also has the capacity to do that. Okay, what happened? Okay, ayaw niya, no? So ayaw ni, ay sorry. Hindi ko na. Hindi ko pa na-try to kay autoplot. Let's see. If it will plot anyway. Yeah, it did. It did. So ito yung 6 by 6 coming from autoplot. But if let me see if I partition and F row is equal to C, kasi this is 3 rows by 2, I make it 2 by 3. Let's see if it will change the format. Kasi 3 rows by 2 to eh. If I make it 2 by 3, run this. Ayaw, no? Default ni autoplot 3 by 2 default ni. So ayaw niya dito. Ay, sorry. Yeah, 2. Kasi linagay ko to eh, 2 by 3. So hindi niya sinunod. So let me just delete this. It does not. Kasi ibang ano yan, iba siyang ano, ibang universe ang plot. Okay, let me pause for a while. Any questions so far, class? Okay, let me change my question. Are we clear so far? Are we clear so far, class? Okay, thank you. All right. The the discussion of the residuals class will be very important, especially for your first case, kasi regression of first case, and you need to really discuss if the model is valid based on diagnostics. All right. Now, let's now go to the next model, which is, let's create now a model 2. So kindly write this class. So I'm creating this model 2, and still use LM. Okay, hourly wage regress on this time. I'm going to use all the functions, all the variables under our wage data set. So we're going to use all of them, the 7. If you run it, what happens? Are you able to generate model 2? We should check your environment. If there's a data there in the environment, then that means that you were able to run it. Okay, waiting for your response, class. What happened when you ran the LM model 2? Okay, thank you. So kay Fe, kay Pauline, sabi niya, there's an object in, in the data and contains a list of 13. How about the others? Error? Let me see. Mark, can you please share your screen?
Okay po, sir.
I'd like to see where the error is coming from. How about the others, class? Could you kindly check if you were able to generate an object called mod2?
Naka-display po yung share screen, sir.
Wait, sorry. Okay, Mark, go ahead. Okay, let's see. So you have mod 2 LM, hourly wage, regression, education. Data is equal to wage. Meron ka ng mod sa baba. Sa environment. Sa baba.
Saan po?
Sa baba, sa environment.
Ayan po. Pero ito
Yeah.
po, this one, di po gumagana sa akin.
Which one?
Pero ito pong second one. Pero itong first and third gumagana po
Kasi
ata.
date nakalagay yun. Dapat data.
Ay, sorry sir.
So,
Thank you, sir.
okay, so now we can see that very sensitive si ano, no? Very sensitive si R sa ano. Sa spelling. Okay. So it run class. It run. Now, I just want to point out that if you were using R maybe a few years ago, this would not have run. Hindi magra-run yung mod 2 class. Bakit? Kasi meron tayong mga variables dito na character. So ngayon nag-automatic na siya. Binago na nila yung yung algorithm para kahit may nilagay ka na categorical, it will be treated as a factor. But let me just backtrack a bit and tell you what we had to do before. So dati, kailangan yung race, gender, civil status coming from the wage data set, kailangan i-as factor muna namin yan. No? So as that factor, wage, race. Okay, why don't you do this class? Siguro before na lang the LM2, i-run natin, tapos tingnan natin kung ano mangyayari sa data natin. Again, as I said, this is not necessary now. But for me, naging parang practice ko na kapag may categorical variable, I convert it into a factor. So this is how you convert a categorical variable into a factor. No? So as that factor. And of course, kailangan yung identify natin, hindi pa pwedeng race lang ha, kasi hindi maintindihan ni R yung race. Okay? So if you run that class, I'm going to run it. Okay? All right, and then if I check the structure of wage, notice now that kanina character yan, no? Ngayong factor na siya. Factor with 2 levels, non-white and white. Si gender, factor with 2 levels, female and male. Tapos si civil status, factor with 2 levels, married at saka single. Now, this is very important, okay? So let me ask you first, kay gender class, kay race, sino yung mauuna alphabetically? So linis na niya dyan, ano? Si non-white. Non-white is alphabetically mauuna, no? If I go to wage class, wage here, okay, si race, ang nauna si white. Diba? Nauna si white class. Ibig sabihin class, sino ginawa niyang 1? Sino ginawa ni R na 1? C? Kasi white, if we take a look at this one, ito 2, 2, 2, di ba? Si white to, no? So, ibig sabihin, ginawa niyang 2 si white, tapos si non-white ginawa niyang 1. Ito female, okay? If we take a look at the data, female muna, no? So, female, 1, 1, 2, 2, 2. Right? So, what R is doing is that lahat ng yung variable na mauuna alphabetically, kunyari married, mas mauuna si married kaysa single, no? Not in terms of appearance in the data class, ha? Kasi dito nauna si white, di ba? Dito nauna si female, si single. Ang gagawing una class yung yung alphabetically mauuna. Okay? So just take note of that class. Just take note of that. All right. So let's go back here. Let me close this. If we check the class of race, control enter. Okay, you can now see that this has become this has been converted into a factor. All right. So I'm running this class. Okay. Purpose ng factor, thank you for that question, Mark. Ang purpose ng factor, as I said a while ago, it's easier really to to work with factors as compared to characters. Kasi ang factor class, nagdi-default sa R na sa regression, gagawin niyang dummy variable. Okay, which was very important before. Pero ngayon hindi na kasi nung rinan yung model 2, di ba? Without you converting it as a factor, nag-run siya. Ibig sabihin, nag-default si R na actually, behind the scene, it is actually converting it as a factor. All right. Let me run the summary. Summary ng, oops, sorry, hindi ko pa pala na-run to. Now, by the way, class, itong nasa taas na to, this is just the same as this one. This one, class, where we regress hourly wage on the 7 variables. No? It's just the same as regressing hourly wage on that dito. So pareho lang yung class. The dot here signifies all the variables in your data, except of course for hourly wage. Okay. So let me now run the summary. Rinan ko na si mod 2 rinan ko na. Tapos summary natin. All right. So just like a while ago, yung summary class will give us. Okay. So take a look at this. So first, you have the call, yung formula na ginamit natin, hourly wage regression all. Then you have the some information about the residuals. And then here you have your regression output. This is your individual t-test, individual test of your parameters. Okay, so what can you see here? Let's now quickly look at this. Intercept became statistically significant. Okay, although sabi natin, significant or not, the intercept will form part of your of your model. Then education. See that the value changed. 574 na, kanina yata 5, if I'm mistaken, 54. So this is around 0.575 and it's statistically significant at 0.1%. Okay, so how do we read this? For every 1 year, since education is in years, 1 year change in education, 1 year increase in education, there's a corresponding $0.57 increase in hourly wage, comma, ceteris paribus. Okay, we have to put that class. Okay, ceteris paribus, which means that all things being the same. What does that mean? You're only going to change education 1 unit. Experience, tenure, etc., you will not change. Okay, you're not going to change it. Otherwise, if you also change experience, let's suppose this is significant, then this will also add to the marginal effect on hourly wage, di ba? Magiging 0.57 at saka 0.02. Kasi magbabago din to ng 1 year, right? So that's why when we interpret each individual variable, each individual parameter, we say ceteris paribus, which means do not increase the others. Okay? So that's what education 0.574 means, 0.575. Okay, experience class is significant only at 10%, right? This is significant at 0.1%. So if we insist on a level of significance equal to 0.05 or 5%, then we reject this. So B1, B2, for the null hypothesis, HO, B2 is equal to 0. Okay, we reject the null hypothesis that experience, sorry, we fail to reject because this is not less than 5. No? We fail to reject the null hypothesis that your experience is equal to 0. Okay, and then tenure class. This is also in years. So for every 1 year increase in tenure, there's a corresponding $0.138 increase in hourly wage, ceteris paribus. Okay, so ganun din si number dependence. If it's significant class, however, it's not significant. Assuming it's significant for every one individual or one increase in the number of dependents, then there's a corresponding $0.146 increase in hourly wage. Okay, that leaves us now with this. Itong race, gender, civil status. Take note that R automatically appends a level here, di ba? Ba't niya ginawang race white, gender male, civil status single? Okay, it has something to do with how your variable is arranged, no? And balikan ko muna yan, class, no? Okay, let me go here. Okay, so I said a while ago that the alphabetization, no? So dito si non-white, okay? Non-white ang mauuna, no? Kaysa kay white. Okay, so what does R do? R takes a look at the sino muna yung alphabetically mauuna. In that case, dito si white. Si non-white pala, non-white, and then it will make this as the benchmark variable. Benchmark value, okay, or benchmark variable, okay, which means that it will get a value of 1. Okay, what's happening, class? If a variable is a factor, pag factor siya, class, ang nangyayari dito, since a factor technically, before it became a factor, it's a categorical variable, right? Pag factor, class, kasi, ang ginagawa dito, dinadamify niya. Dummy variables. So what does that mean? We're going to create dummy variables out of this factor here. So paano nag-create? Number 1, ilan? How many dummy variables? So it should be the number of dummy variables should be the number of levels minus 1. So let's take a look at race. Si race class, ilang levels to? Di ba dalawa? Non-white at saka white. So R automatically assigns a value 1 here. And for white, 0. Okay? Non-white now becomes your reference variable. Okay? So, ano ibig sabihin niyan, class? Ang ibig sabihin niyan, class, na sa regression output, you're going to read si white with reference to non-white. Parang naka-refer tayo or naka-benchmark tayo kay non-white. So, sige, ganito gawin natin, ha? So, si race class, ano mangyari dito? Si race, ida-damify natin to. Okay? Sabi natin, ang ano dito, ang benchmark is the value, the level that appears first, which is non-white. Appears first, class, not in chronological order, but rather in alphabetization. No? So, yung isa, class, dalawa lang naman sila, si white magiging 0. So, itong race sa to, class, mapapalitan to ng, this is white, so this is 0. White, 0. 0. 0. So, lahat ng white, class, 0 yan. Wherever your non-white is, 1. Okay. So, ilang dummy variable to, class? How many dummy variables? Only 1. No? Only 1. Were we able to capture all the levels? Yes. Pag 0 siya, edi white. Pag 1 siya, edi non-white. Dalawang levels lang naman yan. Okay? So, how do you determine the number of dummy variables? The number of levels minus 1. So, si race, 2 levels minus 1. So, isang dummy variable lang yun. Okay? All right, next, si gender. Okay, dalawa lang din, di ba? Female, male. So, si female, siya yung magiging benchmark. Si male yung magiging si female yung magiging benchmark or reference. Therefore, we're going to dummify this. This will have the value 1, 1, 0, 0, 0, 0, 0, 1, etc. Okay? So, practically, we replaced female and male with 1s and 0s. Now, since napalitan na siya ng quote-unquote numbers, pwede na siyang isama sa regression. Di ba? Kasi number na yan eh. Naging quantitative na siya. Okay? Also this one, no? Si single. Ang reference dito si married. Right? So ito, ang married magiging 1 kasi alphabetical, mauna si married. So si single 0. So single 0, married 1, married 1. Lahat ng married 1, lahat ng single 0. So again, na-damify na to. No? Naging quote-unquote quantitative na siya. Now, what happens, class, if you have, let's say, college level? College level. No? So meron tayo, kunyari, may senior, may sophomore, may junior, may frosh, may frosh. Kunyari, data to, no? Frosh, junior, sophomore, senior. Okay, so what will happen here? So, ilang bang levels to? There are 4 levels, no? Kasi, frosh, sophomore, junior, senior, apat siya. So, ilang dummy variables to? The number of dummy variables will be the number of levels minus 1. So, tatlo. No? So, paano yun? Tatlong reference natin. Ano yung mga references natin? Unahin natin. Ano ba yung mauunan alphabetically? Si Frosh, no? Okay? So, si Frosh. So, idadamify natin si Frosh. And this will be a reference. Sino pa? Susunod si Junior, no? So, si Junior. Sino pa susunod? Si Senior. Okay? So, alphabetically, class, alphabetically, si Frosh reference. Si Junior reference, si Senior reference. Si Sophomore lang ang hindi reference. Of course, you can change this class. Kung gusto mong maging ang reference mo si Sophomore kaysa kay Senior, that can be done. But we'll discuss that later on, class. So, 4 minus 1 is equal to 3 dummy variables. So, sige nga, tingnan nga natin. So, Senior class, Senior. Paano siya mare-represent dito? O, Sophomore muna dito. So, si Sophomore, how will you represent it? Hindi siya Frosh. Hindi siya wait. So, Senior pala, no? So, gawin natin Senior muna to, no? Senior. Ihuli na natin si Sophomore. Senior. Hindi siya Frosh, hindi siya Junior. Senior siya. So, 1D. Si Senior, ganun din. 0, 0, 1. Tapos si Junior, 0, 1, 0. Si Frosh, 1, 0, 0. 1, 0, 0. 1, 0, 0. Ba? 0, 1, 0. Pagdating na kay Sophomore, 0, 0, 0. Okay? Now, question. Were we able to capture all the levels? Lahat ba na kayang makapture, class? Lahat ba represented? Kindly chat please or answer yes or no. Yes or no, please? Na-capture ba lahat? I'll wait for your chat, please. Thank you, class. Carlos, you were the first one. Kindly explain your answer. Bakit na-capture lahat? Pati hindi reference variable, na-capture ba? Kasi tatlo lang reference variable natin. Sino hindi reference variable, Carlos?
Sir, among which variables, sir?
Yeah, sino hindi reference among the different levels? Is Frosh a reference variable? Carlos, reference ba si Frosh? Yes. In fact, siya yung unang-una, alphabetically mauuna siya, di ba? Si Junior, reference ba? Yes. Sabi natin dapat tatlong references, di ba? Tatlong
Yes,
dummy variables. Si Senior, reference ba?
yeah.
Yes. Sinong hindi? Si Sophomore, di ba? Kasi alphabetically, ito yung huli. Am I right?
Yes, sir.
Okay, will Sophomore be, even if it's not a reference variable, will it be accounted for here?
No, sir.
No?
Bakit no?
Because you're only referring to 3, sir.
Oh, pero tingnan mo dito, sophomore. Pag tinignan ng computer yan, ng R program, makikita niya, 0 sa frosh, 0 sa junior, 0 sa senior. Sino yan?
The sophomore, sir.
Yeah, so was it able to account even the sophomore?
If it's 0 for all of them, then yes.
Yes, oo, kasi 0 for all of them eh. Bakit if? It's 0 for all of them. Kasi hindi naman siya frosh, so 0 siya dyan, di ba? Hindi naman siya junior, so 0 siya dyan. Hindi naman siya senior, so 0 siya dyan. So ano siya? Sophomore to, class. Pag any sophomore here should have 0, 0, 0 values here. Okay, so you have 3 dummy variables and it's able to capture 4 levels. Pag 1 siya dito sa frosh, syempre hindi siya pwede maging 1 dito sa J. Mag-error yan, class, kung 1 siya dito at saka 1 siya dito. Right? 1 siya sa frosh yan. 1 siya sa J, junior yan. 1 siya sa SE, senior yan. If it does not belong to FJSE, then sophomore yan, 0, 0 lahat yan. Okay, I hope everything clear na yung class, ha? So that's why when you have a factor class, and if you have, let's say, 5 levels, 4 lang yung dummy variables yan. Everything will be captured. Okay? All right, so let me continue class. And let's go here to our, okay. Let's go back to our data. Okay, now, ito na, class. Let's see how this is interpreted. Okay, let's start with the gender male kasi, ano siya, no? Significant, no? 3 stars. Significant at 0.1, and it says 1.75. Now, what is the reference variable for gender class? Kindly chat, please. What is the reference variable for gender? Okay, female, all right? Female siya, class. So, what happened here, class? So, itong si male ang nakalagay dito. Take note, ang linagay niya dito hindi yung reference. So, it tells us that this male should be interpreted with reference to the benchmark, which is female. So, what does this 1.76 mean, class? So, the reading of this is that on the average, so we're saying on the average, no? On the average, okay, a male, no, employee receives, okay, it receives 1.75, I'll just round it to 176, $1.76, okay, more. Why more, class? Because it's positive, so plus siya. Plus female, relative to female, okay? More than their female counterparts. Female counterparts, ceteris paribus, CP. Ceteris paribus. Okay, let me repeat this, class. So the estimate for the gender, in particular the male, okay? Why does male appear here? Because our benchmark is female. Okay? So ito i-interpret natin, si male na to, interpret natin in reference to female. So 1.76. Okay, it would be a good experiment, class, na gawin yung it can be done, class, madali lang yung code nun. Gawin yung 1 si male. Okay? You'll have the same result pero magiging negative siya. Okay, you'll see that, class. Magiging negative ngayon yung pag gender female na to. Kasi ang reading niyan, female employees receive $1.76 less on the average than their male counterparts. All right? So yun na, no? Okay? On the average, a male employee receives $1.76 more than their female counterparts, ceteris paribus. Okay. So assuming, class, assuming that race white is significant, but it's not significant, no? Let's just assume that it's significant. So how do we read this? On the average, white employees receive $0.10, $0.11, rounding off, $0.11 more than their non-white counterparts. Again, this is to be benchmarked. Ang benchmark natin, yung reference natin, yung alphabetically na una, si non-white. So we're going to read white in reference to non-white. So white employees receive $0.11 more than their non-white counterparts, ceteris paribus. Okay, so this might be an issue of discrimination, no? Kasi pero hindi siya significant, no? Okay, ganun din dito class, civil status. So again, kasi si married ang mauuna, so yun naging reference natin. So we read class civil status single. On the average, single employees receive $0.46 less, okay, less class, because this is negative, than their married counterparts, ceteris paribus. Okay, let me pause for a while and seek your feedback class. If there are any questions, or if it's clear so far, clear na lang or not clear, paki-feedback na lang class. I would appreciate your feedback. Clear or not clear? Okay, waiting for the others' response. Okay, good. All right. So, continuing down, class. Yeah. Again, i-off ko na muna to. Okay. Now we have here residual standard error. Notice na mas maliit siya kaysa dun sa una, di ba? Yung isa kanina 3.3 something. On 518 degrees of freedom, where did this come from? N minus K minus 1. N is your 526 minus K. There are 7 predictors. Minus 1, so that's 518. 526 minus K minus 1, that's 518. And then what happened to your multiple R squared? Kanina 16 something lang, 16%. Ngayon naging 37 na, no? Naging 37 na to, no? 36 something. So this model is able to explain more the variability of your hourly wage compared to just using the simple linear regression model education. Okay? And overall goodness of fit test class, degree of freedom 1 is 7 predictors. Degree of freedom 2, yung N minus K minus 1. Okay? P-value is still practically 0. So here, the null hypothesis is, okay, just to show you, overall goodness of fit test, null is B1 is equal to B2 is equal to hanggang is equal to B7. 7 predictors no, is equal to 0. So we reject this null hypothesis that everything is equal to 0. There's strong statistical reason to believe that at least one of this is not equal to 0. And that was shown by your individual t-test. No? Yung values ng education natin, etc. Lahat ng mga significant dun. Okay, pause again, class. Pause again. Clear so far? Again, I'll appreciate your feedback. Kung clear, I'm getting this, trying to get this step by step. Waiting for your feedback, class. Okay, good. Thank you. Right. So, sige, let's continue class, no? Clear again. All right. Now, so this one, I'll just share the code with you and kindly compute for the SSR, SSE, and SST. Okay, we'll just get back to that next meeting perhaps. But you know how to interpret that class. For example, SST is the
difference between your hourly wage, the observed value, and the average, right? So this is your base model. Get the difference, okay? And then square it, and then get the sum. On the other hand, your sum of the squares of your regression is the difference between your fitted value and the mean. Okay, so this is the improvement in your model, the fitted compared with the average. And then lastly, your residuals, SSE, error terms, the difference between your observed value. Sorry, did I say observed value here for the fitted? I'm sorry. This is not the observed value, but the predicted value or fitted value. This is the observed value minus your predicted value. Once again, get the difference, that's your residual, square, and then get the sum. So you'll be able to get your SST, SSR, and SSE. And then, okay, why don't we do this, okay, class? So if I run this, you'll get our SSR. So to print it, I'll just put a parenthesis here, parenthesis, parenthesis. And you put a parenthesis at the beginning, at the end, it will automatically print the result. Okay, so let me put the parenthesis here, and then run this, Control Enter. So there you go. This is your SSR, SST, SSR, and SSE. So you were able to explain, okay, out of the total SST, we were able to explain 2652. Okay, so we can get the R squared to be your SSR over SST. So that's your 37.041 there. Okay, this one. And this one will be your adjusted R squared. So this is the formula. Okay, so let me write that. The formula is simply equal to adjusted R squared. It's 1 minus, okay, so 1 minus R squared, okay, times n minus 1, okay, divided by n minus k minus 1. Okay, so this is the formula. 1 minus the quantity 1 minus R squared times n minus 1 over n minus k minus 1. Okay, and you can use this function which I shared with you. Anyway, I will not anymore unless you have questions about this. Okay, so that's the formula for your adjusted R squared. If I print this, and this book. So you notice here that our adjusted R squared is 35.94. Is it the same? 36.19. Okay. Okay, I must have made something here wrong. N minus K, subtract 1 because it includes the and then minus 1. So this should be correct. Okay, anyway, just help me decipher why it's giving a different answer. It should be 36.19 also. And okay, anyway, let's just decipher saan ako nagkamali dito. Okay, I leave that for a while, class. Balikan na lang natin yan. Let's go to the more important things here. So we said that in terms of either R squared or adjusted R squared, model 2 is better. Okay, because it can explain more the variability of your dependent variable hourly wage. And also, we said a while ago that if we compare the simple linear regression model 1 and our multiple linear regression based on either AIC or BIC, let's see what happens. Let's first run AIC. Okay, so you can see here that For model 1, AIC is 2777. For model 2, it's 2640. So based on AIC, model 1 is better. And then based on BIC, model 1 is also better by virtue of having the lower BIC. Okay. Any questions, class, so far? Based on adjusted R squared, model 2 is better. BIC, model 2 is better. AIC, model 2 is better. Okay, could you kindly comment, please? It's clear so far? Okay, thank you. Okay. Okay, no questions? No questions? Okay. Now, there's a statistical approach, class, to determine which is better, model 1 or model 2. Okay, let me explain this. Sorry. So take note, class, model 1 has one predictor, K is equal to 1 here, right? One predictor. Model 2, K is equal to 7. So if we compare model 1 and model 2, this model 1 is your restricted model. Model 2 is your unrestricted. The model that has more variables, ito education lang. Ito education plus the rest. No? So this is your restricted versus unrestricted. The one with the less number of predictors. Now, ang question, class, sa ANOVA, if we do this ANOVA class, we're answering the question, does it really make sense to add more variables as compared to just one, or to the restricted model? Kasi isa lang to, no? Or whether this is 2 or 3 or 4 or 5. Kunyari, 6 to. Restricted pa rin siya kasi yung model 2 natin 7, mas marami. Okay, so ganun yung comparison ng class, ha? Okay, so the null hypothesis is, HO natin is, the restricted model 1 is better. In other words, class, it doesn't make sense to include other variables as predictors. Okay na yung okay na isang variable lang. Okay, so if we run this, let's run this, ANOVA, model 1 natin is the restricted, model number 2 is the unrestricted. I run this, and let's see what happens here. Okay, so here our model 1 here is the restricted, di ba? Kasi isa lang yung predictor niya. Dito, ito yung predictor siya. So this is model number 2. Now, wag niyo isipin yung number model 1 and model 2 na to kasi this might get confusing. Basta alam natin na ito, yung sa ANOVA, yung model 1 niya, yung restricted. Yung model number 2 is the unrestricted. And we arrive at a p-value. May nag-ANOVA siya, nag-f-stat siya. Tapos, ang lumalabas dito, plus, okay, you have here, residual degree of freedom, 524 to, no? Kasi isa lang yung predictor natin dito, di ba? N minus K minus 1. 526 minus 1, minus 1, 524. Ito naman, 526 minus 7 minus 1, 518. Okay? Tapos, lumalabas dito na ang f-stat is 28.202. Okay, this is just sum of the squares. This is 4508 divided by 6. Tama ba? 4, 5, 6. And then paano nga ba ito? This. Sorry. The difference pala. Sorry, class. The difference between this one and this one is this one. The difference between the degree of freedom is 7 minus 1. This is 6. Ito naman, this minus this yung difference sila. Okay? So, we will be able to generate yung p-value dito. And the p-value is practically 0. So, Anong conclusion natin? Reject the null hypothesis. Reject null. Ang null is mod 1 is better. Diba? The restricted model is better. Okay, we have strong statistical reason to believe that the model number 2, the unrestricted model, is better than model 1. Alright? Clear yung class? So this is, ito yung acid test talaga, yung statistical test to, no? Yung analysis of variance natin. To test whether which of the any two model is better. Okay. All right, then let's go here. So, ang final model na ba natin, class? Ito na yun. Ito na yung final model natin. From our discussion before, diba, sabi natin, ang final model natin, ito ba yun? Hourly wage is equal to this one, negative 3.39 plus significant 0.57 times education plus 0.14 na lang times tenure plus 0.11 times race. Notice I did not put race white kasi hindi naman variable C. In-append lang to clarify, pero ang variable natin is race. Plus, since may hat to, no? So walang epsilon, walang error term. Pag walang hat dito, then plus epsilon sa I. Okay? So that's our model. Is that our final model? The answer is no, class. No. We have 1, 2, 3, 4. 4 insignificant predictors. So what we're going to do now is a process called stepwise regression. So si stepwise regression, class, dalawang klase yan. Stepwise. Dalawang klase, forward and then backward. Okay. Ang mas madaling gawin class si backward. Itong ginagawa natin ngayon, backward to. Bakit? Sa backward class, we include all the variables first, lahat to. Tapos we're going to eliminate one by one. Okay, kaya nga stepwise, step by step, backward, magtatanggal tayo ng variables dito. Ano yung candidate? The variable with yung minimum, pinaka-least, absolute value of t. T-stat. No? So if we take a look at the t-value here, definitely kasi yung mga significant dyan, matataas yung t-value niyan. It will not enter the picture class. So ang lalabas lang dyan class, yung mga maliliit na absolute value ng t. Sila yung mga candidates, sila yung mga mabababang t-value, sila yung mga hindi significant. So it turns out class that, take note class, absolute value, absolute, no? Hindi si civil status. Although technically algebraically siya yung pinakamababa kasi negative siya. Pero ang pinakamababa absolutely is ito, 0.257. So si 0.257 class will be what we call the leaving variable. Goodbye siya, leaving. So one at a time class, no? Aalisin natin si race white. Okay? So let me go there, class. Aalisin natin sa picture si race white. Okay, so let's go here now. All right. So si race white class, so we have now hourly wage regressed on education, experience, tenure, gender, civil status, number of dependents. Naging 5 na lang. 1, 2, 3, 4, 6, 5, 6 pala. Kasi 7 dati. Tinanggal natin si race. No? Or the easier way is model 3, LM hourly wage, regress on everything, and then minus race. Pareho lang yan, class. Negative race. So tatanggalin natin from everything si race. All right. So I'm going to run this class. I'll just run this. Pangalawa. Okay, and I will now have a model 3 and then isa-summarize ko siya. Okay, so I'll wait first. I'll give you a few seconds. We have quite a limited time. Extend lang ako class ng konting but if you need to go, please do so. Para pareho lang tayo dun sa kabilang section. Okay, so this is now our new model. So, intercept as education, still significant. Experience, still at 10%. Si tenure, sa si gender. Si civil status at saka si number of dependents, hindi pa rin sila significant. No? Okay? However, let's take a look at the ano nangyari dito. No? Adjusted R-squared class, it went down. No? Why did it go down? 37.03 kanina, 37.04. Ngayon naging 37.03 na lang. Yes, it will go down class because nabawasan yung ano natin. Nabawasan yung predictors natin. Sabi nga natin class, if you keep on adding, your multiple R-squared will keep on increasing. Okay? However, your adjusted R-squared is the ultimate test because we are penalized for adding more variables. Kasi ba parsimony yung target, parsimony's model. Overall goodness of fit test, okay pa rin, no? Okay, 6 degrees of freedom, 519 DF2. P-value is still way below 0.05. All right, now, which is better class? Model 2 or Model 3? Remember, Model 2 class is the one with seven predictors, no? Ito. 7 predictors to. This one now has 6 na lang. Nabawasan. Okay, and if we run this class, okay, turns out class that mas maganda pa rin si si model number 3, yung 6 predictors lang. Okay, so in terms of adjusted R-squared, in terms of R-squared class, mas maganda si model number 2. Siyempre, mas malaki yung R-squared niya. Also adjusted R-squared, 3631 to si model number 3. Tapos si model number 2, ilan yan? 3619. So, in terms of adjusted R-squared class, mas maganda si model number 3. Okay, so you can see here class na sometimes mas konti yung predictors, mas maganda yung adjusted R-squared. Okay, so that happened here. Ito 3631. Yung isa 3619. Okay, but in terms also of in terms of multiple R-squared, mas maganda talaga si model number 2. In terms of AIC, mas maganda class si model number 3. And now the ultimate test class is si ANOVA natin. Again class, sino ang restricted natin dito? Ang restricted model natin is model number 3. Okay? It's almost time class, but I'll ask for your permission. If you need to go class, you may. Ito na lang, no? HO natin dito is model 3. Ito yung restricted. No? Mas konti siya, di ba? Kasi 6 lang yung predictors niya. And this is the better model. Okay? Si model 2, yung unrestricted kasi 7 yung predictors niya. Okay, let's see if the addition of race, kasi yung race ang dinagdag dito sa model number 2 eh. Tinanggal natin kay kay model number 3. Does it make sense to add race? Kasi tinanggal natin yun sa di ba? Sa model number 3. Let's see the ANOVA here. All right. Right, you can see here that model number 1 dito class, model number 1, wala si race, tinanggal si race. Ito yung restricted natin. Model number 2 natin dito, kasama si race. So, ano yung p-value natin? 0.797. Okay, this is way greater than 0.05. Therefore, okay, failure to reject the null hypothesis. So we fail to reject the null hypothesis that the restricted model is So restricted model is better. We fail to reject that. So mas maganda talaga si model number 3, yung binawasan natin ng race. Okay? Based on this analysis of variance. Okay? All right, so the process will continue. So from model number 3 natin, sino dito yung candidate na aalis? Again, take a look at the p-value. Okay, I will ask you to model this, continue this. Ano yung susunod na ano na aalis yung living variable? So continue class, no? Continue the process, living variable, tingnan class, mag-ANOVA, living variable, tingnan hanggang pag significant na kasi lahat sila, wala nang living variable doon. Okay? So, I hope you do that class. So next meeting, I will not run everything with you. I will assume that you have run yung susunod kay model number 3, it's model number 4, tapos kung model number 5, kung may model number 6 pa ba, no? So, test yung class kung hanggang anong model, and then uh, infer that model, the one with the least number of significant variables, is really the best based on ANOVA. Okay? All right, so let me stop recording first.